All right, cool. Yeah, thanks again, Paul. I think it's wonderful to imagine people around the world connecting through a virtual session. I think in today's world, we need more sessions, and virtually, connecting with people around the world has a bigger impact, on sharing the knowledge, also, getting insights of what people might be missing in the technology, right? So starting with my introduction, I'm Satpal Singh, Associate Director, Cloud and AI Architect. I'm a Grafana Champion. I'm also Grafana and Friends Hyderabad organizer. I'm also a Global AI Hyderabad chapter lead, which is sponsored by Microsoft. I'm a certified Kubernetes application developer as well, right? So before moving on, right, I'll like to tell more about myself. I've been in the IT industry for more than 15 plus years. Uh, with starting my journey as a Java developer. Uh, then we all know the buzzwords of DevOps, and then cloud coming into technology and making things much more smoother, easier to scale. That's where I wanted to see the other side of the coin. And I was quite interested to see how infrastructure is set up, how cloud handles our applications, basically how we deploy and understand the other side of it. So slowly I got that interest, and I was able to get hands-on on cloud technologies plus DevOps. As I was a Java developer, I was very much aware of how application is developed and then deployed onto the infrastructure, let it be cloud or standalone VMs or any other infrastructure. Now, getting into cloud, I slowly developed the cloud computing skills on OpenShift. Back then, there was a time where I used to push the code to cloud using Git commands. So there are only command line executions to push the our Java bundles. And then the UI came up with config maps, and uh, people started using cloud extensively, get a hands-on cloud computing with ease of deployment, scalability coming in, microservices architecture coming in, distributed systems coming in, with the technical products also hosting as a microservices. Uh, that's how vast our architecture is today. And the systems, the distributed systems, and the microservices architecture make it much more complex for teams to observe their systems, right? And everyone on the call will agree with me that now it has become very much complicated, and we need much more tools, observability tools or insights from the systems to understand how they're behaving under load, how we monitor our logs, how we see the events which are triggered in the cloud environment, or standalone VMs as well, right? So observability has become a critical component, and many are. Of course, no, we can't. I would say we can't achieve 100% observability because the technology is changing, the infrastructure uh, is changing. Now we have got GPUs, AI workloads. There's a big demand to reduce the cost of it, and then how the performance and security can be monitored, observed, right? So there are so many things coming up, and when you talk about quality assurance of it, we need uh, good tools in the market to observe the systems and also get a report of it, right? So we need a live dashboard, maybe, that can actually help us understand, okay, when this event happened, or what happened at this time, right? So. coming up back to the topic, right? So it's like we apply now the load test using K6. K6 is a Grafana product, and we see how the data, the metrics is captured using the observability tools, which is again provided by Grafana Labs. And we see beautiful dashboard which actually shows us the number of requests applied or applied then failed. And more importantly, you will see here what is distributed load testing. Okay, yeah. So just this was like the uh, evolution of how technology got evolved, where we have today, sorry, what we have today, as an architecture, right? So there are microservices architecture, there is distributed systems, right? So I'll also I have a demo, which is simple demo, which gives you helps you understand how K6 can help us drive these test cases, not only a simple test case, but we can have uh, all our test cases covered for our distributed systems and for microservice architecture, right? So just coming to the agenda, you'll see what is distributed load testing, why the Grafana K6, it's a cloud native tool. Just a list out of like K6 versus other testing tool, architecture of the demo which I'll give, and I'll switch to the demo, right? So basically, we understand, right? I mean, most of us in the call would be aware of or the microservices architecture or the distributed systems, and how the applications are actually uh, you know, the APIs are called, right? There might be UI APIs, or maybe there may be backend APIs, which has a load on that systems. But the question again remains is, how do we simulate that heavy traffic load on these distributed systems, right? Considering a simple example, in our day-to-day life, right? We log in into our um, workspace, which is our company's network basically, right? And just imagine that it's not the case that we all log in at a time, right? And it's not that we always have the same amount of traffic at a given point of time, right? So everyone would agree with that. Sorry. Now, what happens is there might be some users who might log in at 10 a.m. Some users might log in at 12 p.m. Depends on the shift, and there are random logins throughout the day, right? And the same scenario is with our APIs or the application APIs or any other product, right? The request comes randomly through multiple machines, and of course, everyone doesn't log in into the same machine, right? So there are different virtual machines, which means the request is coming across the network from different IPs, maybe different regions, right? That's what we understand. Now, in like the traditional tools or we have in the market today, they have like the simulation was more of a single machine, producing the load at a single point of time, and there were no proper tools to capture the report as well, and they all are like licensed, costly. If you also want to set up a distributed load testing kind of setup, which the example which I have given, right? Generating load through multiple machines and capturing the report, it will cost us definitely, because the tools which are present in the market, you will see the tabular form where I have listed out the tools. What happens is most of the tools are licensed. There are freeware, but again limited features. The way it handles is, they create a master machine, then slave machines, and the setup is quite complex, and you need to pay for it, right? So here K6 is, it's open source, free of cost. It's only the compute cost while you test, right, from the machines, the virtual machines. It's only the compute cost which is being billed for your subscription in case of Azure or AWS or any other cloud provider. Right now, by the distributed load, right, the testers can actually mimic or give a more realistic traffic pattern, as I was explaining, for large scale applications, microservices, APIs, and technical products as well, right? Now, importance of distributed testing, load testing, as I've already covered, right? So we like enable testing with thousands of millions of users, load across multiple machines, simulate real world traffic. I was giving example, or considering any other scenario in the real world applications. For example, in the mark, I mean, we all use internet banking, right? uh, uh, or maybe a branch, a bank's front office, where they have multiple tablets with them, and systems who are opening an application for the bank. So if you consider those real world scenarios, how would you actually test them, right? Generating a load from single machine doesn't actually simulate the real world scenario, right? So the importance of distributed load testing is that we actually see that we generate the real world traffic from these testing tools, right? So it also helps us identify the performance bottlenecks, latency issue, and what are the limits under heavy load. So we do have service mesh, which actually handles all the requests coming into the server. We can know the limit of how many requests per second that service mesh, let it be Istio or Nginx ingress, right? We would be able to know this is what the performance bottlenecks can be identified. And before going into production, we already know the threshold values of, okay, at this rate, the service mesh will break, right? So all these can be tested through distributed load testing, and that gives more confidence to a team that, yeah, we have done our quality checks, and this is what our performance report says, which is also captured in Grafana. That's like a real-time data you can see, and also historical data that depends on the tools. I will show you what tools I've used and how it happens, right? So, and again, it validates scalability as well. Let's say we have an application running, with certain amount of CPU and memory, right? By applying the load and through distributed load testing, of course, the ideal scenario which we have in today's world, right? How the scale, to what extent the application can scale, right? Let it be cloud or on premise. We can put the load. We can see that, okay, at this point my application breaks, right? So the breaking points. This is also called break test, right? So there are different types of tests we can simulate, but the important part here is about the distributed load testing, and what are the tools in the market, and how you choose the tool for in terms of cost, in terms of understanding of the tool, in terms of writing your test cases, and choosing the
Sorry, Satpal, are you still there? I think your audio might have gone. Yeah, we can see your screen again. Thank you.
pretty cool.
Well, we did anyway.
Right now.
Now we can.
All right, yeah, yeah. Okay, apologies. Yeah, so I was there with the uh, how important is the distributed load testing, right? And the systems, the architecture which we are on with the today's technology, right? Now coming to the tool, right? I mean, why Grafana K6 as a testing tool? Right. I think I have given enough justification, but yes, still I have tried to list out the some of the key points here. Why it's so powerful performance and load testing tool. Uh, Give me one minute, there's some overlay here. Yeah. So why this K6 is a powerful performance and load testing tool, especially for cloud native environments. And it's not that today's demonstration will be for on cloud, but it is not limited to cloud. We have K6 Studio, which has recently come up to ease the load of testers to code it, uh, to have the test scripts written by them. That Studio gives more, uh, there's a less learning curve there. But yeah, it's still not fully. You can say like fully tested on, but yeah, you can start with it. And I think it's a desktop application where we that can be connected to agents. So the K6 is not limited to cloud testing, but the important bit here you need to understand is when you use K6, there are different scenarios with your applications, infrastructure, environment, right? So you need to choose the best one and also remember about the cost, right? And know how best you can use while we have distributed and microservices architecture, how best you can use if you have a simple application running on your Windows server, how best you can have the K6 with a simple image on your virtual machine, plain vanilla Linux machines, or any other infrastructure, right? So you I mean you need to choose your best tool to understand how it is cost effective, less learning curve, and what best results and reports does the tool gives you, right? So you can explore on that part, but yeah, ideally K6 is quite powerful and it's evolving, with the current scenarios which we have in the technology. As you can see, I listed like scalability and distributed testing. I've already given overview of distributed testing. Yeah, but scalability, if you have let's say we can simulate 50,000 users with K6, right? Right, that's the big number, and we can also have multiple jobs running the same iteration, right? I'll show you the script as well. But yeah, no, these are some of the key things which gives me, at least for me, the ideal tool for testing, for looking into the performance of my system, right? And it fits well with the integration of our Grafana stack. The K6 by itself generates metrics. Many tools do not do that. And K6 also helps us define our custom metrics with respect to application. Right, I'll also show you that in the code. But yeah, so these are the key points. It's cloud native compatibility, automation with CI/CD tools like GitLab, GitHub, or any other Jenkins, TeamCity. It's quite easy, and it's also independent of any of the CI/CD tools because it's a cloud native application, the K6 itself. So it's just a deployable component on either cloud or standalone machines or any other infrastructure, right? So irrespective of your CI/CD, the code very well works in all the infrastructure. So it's quite compatible with the automation and CI/CD. Again, lightweight, and also developer friendly. Not only the testers, but developers can also use for their unit test or to have subsequent calls in the API. The payloads can be passed from one API to other API. So we all know, right? There are so many scenarios, there's so many technical products coming in, like Redis is one of the popular product for cache mechanism, right? That also is deployable on cloud. It's also deployable as a bundle on plain vanilla Linux machines, right? So how would you actually test the performance of Redis, right? So K6 makes it possible, right? So it's like, because it's more of a as a code, right, written written as a code and more of cloud native friendly, it can be extended. Okay. Now, I'm sorry, open source and cost effective, right? So as I told, it's open source tool. It's available on GitHub. The public images are available on GHCR.io. I'll show you that as well. So it's cost effective for sure because testing. It's not that we are always running the test cases, right? So what we need to understand is how effectively we use these tools to also not impact our cost, compute cost, basically, right? So when you have these test cases running, most of the times load test is one-off case, right? Once in a month maybe. But if you want a sanity test to be done, right, you need to be you need to just assess your environment and build up your test cases accordingly, so that you use this tool effectively, right? So this was about the why I have chosen K6 testing tool. Let me go to next slide. Uh, yeah, here you can see I've listed out the features of K6 versus other tools, Gatling, Load Runner. There are many tools coming up in the market with regards to how the how your systems can be tested, how you can have load testing, break testing, stress testing, and all types of testing that can be covered, as well as the reporting part, right? It's very important how you report, have dashboards created, and once you have the dashboard, you can set up alerts, with K6. That's quite effective because it pushes in the Prometheus compatible format, which can be easily identified by Grafana. And Grafana can have alerts set up on the performance. If you see that, oh, right, when you run the test, if there is the error rates are more than the success rates, you can have alerts configured through Grafana. And in enterprises, they do also need incidents, right? And then based on the alerts, you can automatically create incidents, in whichever tool you use. For example, ServiceNow, or other. You want to create an issue in GitLab or Jira, right? So all type of webhook configurations are available through Grafana, right? So these this is like the versus of K6 tool with with others in the market. Of course, one, like anyone can argue about there are so many tools in the market, why we want to go for K6 only. Gatling is also providing a lot of things, but if you see the language, right, it's simple JavaScript for K6. For Gatling is Scala. The learning curve is more for other tools. There are open source, but very much limited with Gatling and Load Runner. Uh, then the protocols supported are much more higher for K6. As I said, it's a cloud native tool, right? So you can even replicate the Kafka uh, topics, right? And with the K6 simulation itself, you can actually create a topic, put a message, and understand how what's the depth of the topic, what's the threshold of the topic, or any other, because Kafka is now popular in terms of like messaging tools, right? So many enterprise applications, or many of them use, because it's fast processing with the messages, and it's event driven tool, right, basically. So all the protocols are supported by K6. That might be limited with the load runner and Gatling. Ease of use, again, it's modern CLI, and easy to use. I'll show the code, how it works. Again, integration with all the popular observability tools, in terms of capturing the metrics, in terms of display, not yeah, displaying the metrics on Grafana, right? And the cost is again, free of cost because it's open source. It can be just the public images are available. Use Kubernetes deployment just to deploy the images, and just see, anyhow, everyone needs to prepare the test cases. It's not like it will come handy, because every app and their features are unique, and the naming conventions or other things are very much unique. The APIs are itself unique, right? So you need to be careful while designing your test cases, but the learning curve is less. It's very much simple. And with current, chat GPT, and we have chatbots very much prompting us with all the test scripts within minutes, right? Yeah. So this was like, just to give you idea of, why K6 and the other tools available in market versus, these things. And the cost per se, we only have to the, compute cost of the virtual machine which we use, right? Oh yeah. On top of it, just to give you an idea of SLO, SLIs, how they can be measured with these performance metrics ideally, right? I'll not demo it, but we ideally, from application perspective, we want to know the service level objectives of that API or as a feature of that application, and what are the service level indicators. Right, so the service level indicators are the success of the request, the total request, or the error rates which we have, right? So those are our indicators, the service level indicators. Ideally, the service SLO and SLI is that, which matters, right? So at the start of the day, business day, the application should be up and running, right? And testers are very much, setting up sanity tests or other tests to see that the application is up and running always, right? So in that case, and test environment as well, in production as well, right? We can do a sanity in production for production APIs as well, right? There's no harm in doing that, yeah. Before start of business, I'm saying. So in that case, you will understand, okay, what are my indicators? In this case, I've taken service mesh because that's the entry point of any request to the server, right? So this is a classic example again. And then we have SLOs, whether it says, okay, 99% of the time my API should be up and running, right? So all this happens behind the scene with the metrics which is created by K6. Okay, so there are other cluster metrics as also available, but for our particular case, or for the particular test which we design at that time, let's say for start of the business hours, for some applications it might be end of the business hours, for some applications it might be some other time, right? So you can define based on the outcome of the metrics, plus the have the service level indicators measured through those metrics, and object set the objectives, right? 99% of, maybe some of the applications might not require to run on a weekend, right? So that happens, they might shut it down. But if my observability is continuously running and it shows, okay, weekend there was no, I mean, there was request, no request, or maybe it considers in that as an indicator on weekends as well, right? So it might be a problem. Your objective might not show the correct value, right? So you can always have these K6, or the K6 tool to sorry, uh, have those metrics, or through pipeline you can ignore the weekends, right? So all sorts of possibilities are available with the K6 tools. So SLO is just to give you an idea, right? How, to what extent this tool can give you insights of, and ultimately it's the SLO and SLI that matters, right? Now coming to the actual architecture of, I've spoken a lot about the K6 tool. In this demo, I'll be using K6 operator, because K6 is a single image which can be run on a single machine. But K6 operator is a mechanism, is just an extension of K6 itself, which has two components, initializer and starter, which actually measures the our whether the scripts are correct, whatever we have defined as the syntax, right? So it initializes and starts our test script ideally. So these two components are very much important for K6 operator. And test run is a custom resource definition. In this, you just need to add your test script and certain parameters, like to to push the metrics, to write the metrics to Prometheus, right? So there are certain parameters which I'll definitely show the code, right? How it is designed. But the important bit here you see is the job one, job two, job three, job four, right? When you define in the test run, and again, this parameter depends on the application requirement or the infrastructure requirement. How many jobs do you want? What is the simulation model you are using here, right? If you want 10 jobs, it will pick up from your 10 virtual machines, which are like nodes, right? Each node on a cluster is a virtual machine, a single virtual machine. So if there are 10 nodes, there are 10 different virtual machines. So what does test run ideally does it? It distributes the load among these virtual machines. So this is very much important in terms of simulating your applications in a real world application scenarios, because as I already told, the uh, having a test case run through a single machine, generating load through a single machine is not the ideal case. So every application is accessible through different sources, through different regions, right? So ideally to simulate that, we have K6 operator here. And on the left-hand side, you see we can deploy the K6 operator, execute the test script using GitHub, GitLab pipeline, or any other pipeline with a single click job. Right, so K6 operator will be deployed once you have your test scripts. Those can be also deployed with a single click job, right? Now, this is like basic architecture, and ideally K6 itself generates metrics which are returned to either OpenTelemetry or Mimir or Prometheus or Cortex, uh, any metrics compatible backend tool, right? So K6 generates, of course, in the market we have tools which are Prometheus metrics compatible to the large extent, like 99% of the tools which are there based on Prometheus metrics compatibility itself. So K6 generates that the same format and it writes to the backend tool. It may be OpenTelemetry, Mimir, Cortex as I listed, right? And ideally, that data source is configured in Grafana. So not only for your performance test, but in the ideal scenario, your application or your infrastructure might have this setup already done. Yes, because you might have a tool to write the logs or tool to capture the metrics, right? So it's the same endpoint. You just need to write the metrics from K6 also. Okay. And of course, Grafana is already configured with that. You'll see that in a bit. Okay. Uh, yeah. Any questions till here? I mean, I'll jump to demo then.
Yeah. Hi, Satpal. This is Venkatesh. I've got
Hi,
a quick
Venkatesh. Yeah, tell me.
question. Thanks for the
Yeah.
brief so far. Just a quick one. I mean, years ago, I remember doing distributed using Load Runner.
Uh-huh.
Hi, am I audible?
Yeah, you're audible.
Okay, good, excellent. Just a
Yeah.
quick one.
We
In
can hear you
terms of,
fine, Venkatesh.
okay, thanks, Paul. When you do have multiple nodes, right? If it's a virtual machine, is there an opportunity to adjust the configuration of the virtual machines to avoid things like kind of self-throttling or the network connectivity? Like, what's the view on that? I'm not too familiar with this setup.
Yeah, yeah. No, see, uh, the 10 nodes, right, was just an example. Okay.
Yeah,
If you
whichever number,
have,
yeah.
yeah, whichever number in the parallelism parameter you give, let's
Okay,
say two, there will be only two jobs. Considering 10 nodes, it will not run on all the 10 nodes. It will
yeah,
only select only two nodes,
understood.
right? So the job is distributed among the two nodes only, and the number of virtual machines we give and the iteration, right? So based
Yeah,
on that, it will just iterate in the two nodes only. I mean, it
sure.
generates the load from the two nodes only. It will
Yeah,
not go beyond two nodes, right? Again, that's a very good question because, as I said, uh, my code as is might not be compatible or work for everyone here, right? On this call. It might be the case that you might have a different requirement. You need to just assess, okay, is my parallelism number of jobs which I want to execute is correct or not? Maybe I'm giving too much of parallelism, right? So it might be the case. But now what happens is if you have 10 nodes and you give 20 as a parallelism, right? There might be cases, there might be heavy applications or maybe so many APIs considering the
yeah,
microservice architecture. So it might be the case, but it will again, because we only have 10 machines, we can't go beyond 10 machines, right? So it will not scale, but it will adjust those iterations within these 10 machines only.
Correct.
right?
No, I
So,
understand that. So the workload modeling would be important for this.
right, considering load runner, right, you need to create 10 machines. But here, you already in your cloud native environment have those virtual machines,
Right. Okay.
right? So
I
if you
see.
go to load runner, it's again enterprise, it's a
Yeah.
commercial licensed product. Every time you need to adjust something, right? You need to I mean, you need to go for billing, and it might take months for them to create a machine for you, right? And that's quite possible, right? I mean, you might have a urgent scenario to test, but if you don't have infrastructure, then you just wait, and then something might happen in the production, right? So but here the cloud native tool, you can scale the nodes. Again, this is scalable product, right? You can scale the nodes. You can have maybe adjusted nodes, max nodes still. And again, it depends on the virtual machine family which you select. And
Yeah.
then you go to maybe scale 20 nodes, and then you do a real-time scenario and shut down the other 10 virtual machines by scaling them to 10 again from 20,
Yeah. Yeah. Okay.
right? So that's how you save the cost, right? But this important bit is you're testing your real-time scenario.
Right.
You can't tell that, okay, from one machine I have generated load at a time, and these are the results. That is not an accurate result and not a right way to test our distributed systems or microservices architecture,
Yeah. Okay. No, thank you for that. Thank you.
right? Yeah. Okay. Yeah, let me go to the demo now. So I have my AKS cluster up and running, and here you can see uh, I have a namespace, called observability, where I have deployed. You can see Mimir. So first thing I'll go for Mimir. Mimir is a Grafana tool, which is Prometheus compatible metrics. Uh, you can say it holds the metrics, right, in Prometheus format. So any tool, any application which generates metrics in Prometheus compatible format can push their metrics to Mimir. So Mimir has a storage by itself, so it can store. I think 3 months is the retention period. That again, that can be configurable. And if you see, Mimir has got certain components called ingester, gateway. Gateway is the one which is exposed for as an API, which actually accepts, like, and as I said, right, metrics can be pushed through the Mimir Gateway API. And on Grafana as well, I'll show that on Grafana as well. We'll be able to see that the Mimir Gateway is configured as a data source. Okay, so this is one component. We have ingester, which will ingest the metrics, which has been pushed to Mimir. So Mimir Querier is the one which is actually exposed to Grafana. There's a slash Prometheus API which will actually query. So we have got component called Mimir Querier, and storage, of course, to store. So I've got sample app, Nginx app. Let me still see get the service names here. See, I'm doing it on cloud, more or less, in this uh, call, uh, you'll see similar kind of setup, right? It's a Kubernetes cluster basically, but I'm on AKS. Let it be web app or any other hosting mechanism for your application, but the components are the same. The you would need a service, right, as an endpoint to expose, right? So here, if you see, okay, let me start with Grafana. So I've just taken the Grafana load balancer IP here to expose the Grafana service, which runs on 80 port. And see, as a tester, right, it's very important to understand how this infrastructure as also works, right? It's not only about API testing, right? So you also need to understand the underlying infrastructure. How does it work? Yeah. So let me log into store. Mm, Okay. 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 Fine. Just because there was a blackout, right? I mean, I lost my, I think, password. Okay, that's fine. Not a problem. Right. So you have seen that, right? So I have Grafana. Um, then Mimir. Mimir is just to write the K6 metrics. Okay. And here I have the sample app, which is again exposed to the external IP, which means I can access my application through this IP. All right. Okay. Okay. HTTP, because it's a load balancer IP. It's not completely. Yeah. So this is my sample app. If I do auto refresh, it just refresh, like go on hitting the request, right? Uh, right. So I have got Alloy, which scrapes basically the metrics logs from this namespace, so that we can see the container metrics, the pod metrics. We have components like kubelet, CA advisor, which gives the Kubernetes object metrics, which gives the Kubernetes container metrics, right? All those metrics for this application as well. We'll see that in a bit. And yeah, here you see the K6 operator controller. Basically, this is then the operator which I was talking about in the architecture diagram, right? Which actually runs the custom resource definition, that is test CRD. I'll show you here, right? So now I'll go into. So we have seen Mimir to capture the metrics, K6 metrics. We have seen Grafana is up and running. We have seen our sample app here. We have seen that deployed K6 operator controller. So K6 operator is like one-time deployment. Then you can apply uh, how many of your test cases are there, right? You can simply just apply through kubectl apply or any other, like if you're using Helm or any other use case. Everything can be pipelined. I mean, as a user, you need not worry about it always, okay, I need to run kubectl. This is just for demo purpose. But once you create a pipeline, no single click job, right? You you need to just focus on the metrics part. This one, this is the yeah. Now here you see this is actual JavaScript which imports the K6 HTTP library, the JavaScript library. And here are like some of the functions called check and sleep, which needs to be imported. I'll show you in a bit. Yeah, so here is our stage, right? So now you see the duration 1 minute, target 10 virtual users, right? So what we are doing is, as I already told you about the ideal case, right, where not everyone will log in at the same time and not for the same duration. It can be random. Now, if you see here, right, we are staging our use case. Whatever use case from my perspective for my application. Let's say this is my use case that I need to test. So I need to define the stages, or else you can simply define there is a VUS, parameter as well, that will execute only one time. Okay, stage is something where you can mention the duration. Virtual users is one more parameter where you just have like one time creation of your users. Okay, but yeah, ideally, as far as I have seen, right, it's all about the ideal scenario, having multiple stages. So this is what easy. You just need, as a user or tester or the developer, you need to understand, okay, this is what my ideal scenario is, and you can have that as a staging. So on Grafana, I will show you how this stages looks like, what is our HTTP success count, failure count, and other, right? And yeah, here you can, this is again interesting, right? So you can actually define the HTTP request failed. So HTTP request failed is a threshold, it's a metrics. You can say that, okay, the rate of failure should be less than 0.01, right? So now you see how powerful this tool is, because you have full control on the parameters. Okay, if you consider other 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 tools in the market, or maybe other implementations, right? Even I think K6 Studio doesn't give you the leverage of having these bundled as a code, right? Like you're writing a test case, but it's very much pretty much simple, right? You just need to follow a syntax, and you can have, like, give your threshold is in a keyword where you can based on the metrics. I'll show the log output here. Based on the metrics, right? If you say, because most of us will be looking at, okay, what is my how is my P95 looking, how is my P90 looking, right? So percentile of my request, it should be less than 500. If it is great, I mean the number count of P95 is greater than 500, then it will go into failure. It will not, here you see the check, right? So status is 200, right? But here we are also given the threshold. If the P95 is less than 500, then it's okay. But if it is more than 500, so I'm defining my threshold, right? Now you can see how easy, or you can imagine your own scenarios, how you can actually draft a test case using a simple JavaScript, right? So this is a sample example how you can use stages, how you can use the thresholds here, right? And ideally, what we're doing is we are hitting this application. So 20.36.35.7. So this is our application. We are Yeah, we are sending requests. The virtual users are here, target 10 for 1 minute duration, 2 minute duration, and then again 1 minute duration, 0. We are just ramping up and then ramping down the users to see the performance. And ideally, it will check the response. Rest is here, right? So status is 200. Yes. Sleep for 1 minute just to give a gap, because it happens so fast, right? I mean, the execution happens so fast. So we can just keep sleep one so that it executes a bit slow to fire the number of the virtual users one by one, right? Now, let me show you the test run file, cat k6 test run, right? Yeah. So here, yeah, the one which I was mentioning, parallelism 2. So that here is the actual key. You need to decide that for distributed loading, for ideal scenario, how many jobs you need to run. So parallelism will take account into the number of jobs. If it is 5, the same test case, which I have as a script I have shown, right? The same test case will execute for, let's say here in this case, 2 jobs. If it is 10 jobs, but the same test case and iteration for each job, right? So you need to be careful when you define the target as well, know how much target. But see, ideally on Grafana, I'll show you the dashboard, how it looks. Ideally on Grafana, you'll be able to see that uh, how many requests have been hit to the API or sample application, and if there are any failures or not. And that would be a live dashboard, in the sense the moment you execute your test case, it pushes the, here you see Mimir, right? The one I was talking about, push API. Okay, so it pushes to the Mimir. Mimir stores the metrics, and on Grafana we have the uh, we have the dashboard, the data source configured so that it can actually pick that source of the metrics, right? So this is just again, this is all one time setup. Once you set this up, right, you need not change anything. You need to focus more on the your test case part, but you have the full control. Let's say, for example, your organization, or you have decided to change the tool from Mimir to any other tool which is good in market, which is cost effective, right? You just need to change the URL. That's it. Okay, so your setup should be so much decoupled that your focus should be on test cases, remaining all the parameters that like pushing the metrics or having like parallelism or dependency or on your Git sorry the CI/CD pipelines, all should be decoupled. You should be more focused on your test cases rather than having the tools changed, and then your implementation also gets affected. So that should not be the case. In the tools in the market, right, they have so much dependency on their own implementation. If there is a new technical product coming in, or maybe there is a change in the CI/CD tools or any other tools, observability tools, they need to change their entire implementation itself, right? But with K6 and this setup, the K6 operator setup, right, there's limited scope of change in uh, any of your implementation. The focus will be more on the, adding your test cases. Test cases, you can leverage because again, I'll show you the extensions as well. There are so many extensions available for K6. Even you can develop your own extension using the K6 has community has provided one XK6 bundle by which you can create your own extensions as well. Just for example, right? So for testing, let's say for database connectivity from K6, because if you want to see a scenario where my MySQL database performance needs to be assessed, right? So no, there are I think MySQL, PostgreSQL, and Oracle DB implementations already available in the extension. But let's say there is a new database tool available in the market, and like K6 doesn't have that extension. But you can also, because to connect to a database, we all know, right? To connect to a database, we need a driver of that particular implementation, right? Or for example, Oracle, we need Oracle driver. We do have tools like Toad or other or desktop application which comes with a driver, but ideally, if you want to connect it, you need to have a driver, right? So using K6, you can actually add the driver into your image, and then it's just 1 day job. That's it. So if at all you have new products which are not really accessible through K6, it's just 1 day job through the extensions. You can create your own image, and you can write some wonderful scripts here to actually access the database, right? So that's the actual it's unimaginable. There's no limit for this tool. It can be extendable to all the limits, and being it cloud native, it gives the full leverage of whether in future, let's say we have AI workloads coming in, there are GPUs, there are chat streams, right? There is a talk about how we can secure these chats, right? To test all those scenarios, the same tool is enough. You need not have again change your tools or implementation or look for some other tools in the market. The same tool, because it's cloud native, GPUs and the AI workloads again run on Kubernetes itself to max extent. So this tool is again ideal. You need not worry about in the future if there is change. You need to change the tool as well, right? So minimum configuration, but there is a maximum impact on your test cases, because current tools are not really fulfilling the scenarios which are because as I said, right, we have microservice architecture, we have distributed systems. Even testers are not finding the right tools. Maybe to some extent they are happy with the current tools, but yes, with this tool you can actually have the real world scenarios replicated. uh, Not 100%, I would say, but yes, 99.9%. It's and K6 also have a private load zone, custom resource definition, uh, which actually generates load from multiple regions. Let's say, for example, Azure has like multiple regions application. For example, there's a common application which is accessible in multiple regions, let's say India, US, and UK. How would you test this scenario, right? Quite complex. Okay. But through private load zone custom resource definition, the K6 can even test such scenarios. So you can imagine how powerful it is. If you consider load runner, Gatling and other tools, right? They just say, yes, it is possible. They need to set up virtual machines in each region, and there's blah blah blah. There's so much of setup they need to do, and it will cost you so much just to test a scenario, right? So the tool should be easy enough to accessible. Easy enough to scale, easy enough to extend the current scenarios, right? So yeah, now we talked about the script, we talked about the test run, how parallelism works, how we push the metrics. Let's see the logs here. Hope you guys are following, right? I mean, it might be like too much of information. Sorry,
It's great stuff. Thank you.
right. Oh, I miss I every time. I don't know. Yeah. All right. Now, just in the interest of time, right? I've already applied that test run which I was shown here, right? So this is like just kubectl apply that file. The two components which I talked about, right? The initializer. Okay. So first initializer checks the entire syntax of my JavaScript and other if there is a comma missing or something missing, right? Then starter will start. Here you see the image of the starter as well, right? So we have given images for starter and runner. See, all this is available. This is open source. Okay, so you just need to add if you're working in enterprise company, or you don't have access directly to the public image, right? You can onboard it in your private nexus and then just give the appropriate registry here, the directory, then you'll be able to access the image smoothly, right? Okay, so I've given parallelism 2. So you see here two jobs, right? So let me just show you the logs here. How does the logs look? Here you go, right? So we have defined thresholds. So the here check says all passed. So P95 was less than 500. This is the measure of P95. HTTP request failed, 0. Okay, that's great. I mean, the rate which we have defined. So all passed. Uh, Checks total, the checks which we defined, right? Checks as a function. So yeah, here is the number. So 2,739 with the target users which we define. Let's see that script again. Right. So we have defined like 10 in 1 minute. So it will iterate. I mean, in 1 minute, how many users it can iterate? It will iterate. It's not like only 10 virtual users in 1 minute. So, but we are giving like target should at least reach 10, right? So it can go beyond. For 2 minutes, at least it should hit 50, right? So again, K6 in the background will take care of it. So that's the beauty, of we just need to define our use case. At the back end, it will take care of iterating, and you see the number here, right? The number is like 2,739. Okay, but at a time you can define 50,000 virtual users here. Now you see the impact. Even I generated over an hour around more than 1 crore of requests. Believe me, I did that, right? So in a large scale enterprise complex systems, right, you can do that. Yeah. So again, it all depends on your scenario, how much capacity you have as a compute, but yeah, considering overall accessibility of the tool and ease of using it, right? The K6 is quite powerful. Yeah. Now total checks, 2739 checks succeeded 100%. So 2739 out of 2739 were success. They were all 200, right? And checks fail is 0, obviously, right? So all pass means 0 fail, right? Now this is quite important. It gives you the metrics, the request duration, how much is the average, how much was minimum, the max, the P90, P95, right? You can also define custom metrics. Here are the standard metrics which K6 by itself provides us. Let's say you want to have P85 as well, right? So you can actually define in your test run somewhere here under environment variables that you need P, because this response holds here. Yeah, this response which we are doing like HTTP GET for this application URL, this response holds lot of data, but it's not it's not that you just need to blindly push all the data, because it does hold a lot of data which as a response we get from get, post or put calls, the methods of the protocols, right? But it is not necessary that no every no, each and every data should be pushed to your backend observability tool, right? So for that reason, K6 has provided a standard, and this is, I think, uh, the bare minimum metrics which everyone would require. So under network, you'll see how much data received, how much data sent. This is again a critical metrics for testing, right? So you would also see that, okay, oh, this much, because some applications might have downloading of PDF files, some might have uploading of PDF files. In that case, you would see more number here, like in GBs maybe. Okay, so how would you handle whether your network, by this data, you are assessing that, all right, so this is the threshold. After this range, maybe if concurrently 100 users upload a PDF file of under my application. So you can test that scenario as well with K6. Okay, you'll get the amount of data used in that time period, and you can tell, or you can capture and tell, you can assess to the management or other teams that hey, you see the network usage is this much. What happens if we have a user base of 1,000 rather than 100? Whether my network is sufficient, the bandwidth of my network, is it sufficient enough to handle such request, right? So this is what the assessment or the performance you get the insights from by doing this real-time checks, right? So you have executed your test case, it gives you output within I mean, again, it depends, like if you have 1 hour, 2 hours, post that you have your metrics ready, it pushes, the metrics is pushed to Grafana. I'll show that in a bit. But yeah, this metrics is really, really important. Like it gives you the basic data, iteration duration, number of iterations. As I said, right? Iteration is different and the target is different. The number of virtual users you define is different, and the iterations is the number of requests which was actually hit to that API, right? And we virtual users max, so it went like 25 within that time. Okay, because we are given time as well, right? Target 1 minute, 10 only. Target this minute, but the iterations will be increased. Okay. So I hope this information is like quite uh, important for all, and now where you actually go and check this information, right? So just give me 1 minute. Meanwhile, if you guys have any doubt, I just need to check the Grafana uh, password where I stored in the system. Meanwhile, now if you guys have any sorry, questions, you can just maybe on chat. I don't know.
Has anybody got any questions I'd like to ask right now? We'll keep it fairly short, but this is an opportunity to ask a few questions, 1 or 2 questions. You can either ask in the chat or you can ask in or just unmute yourself.
Yeah, hi, it's Venkatesh again. Sorry, I'm full of questions usually. Satpal, the
Go on.
example that you've shown at the moment, right? It was, in my view, it's more towards a unit level, right? Because in that example, if I'm not mistaken, we wanted to access that URL which just had a static a simple page and just response for that, right? Given the data that's been transmitted and received, it's a very small microservice, let's say, right?
Right.
In some cases, right? And you alluded to it earlier on that you might have microservices that fetches user data. Okay,
Right.
that's not necessarily a standalone. What's your experience in having a complex setup? for load testing using this K6? Multiple pages, for example, or nested data sets within those pages. What's your
Right.
experience like on that? And
It
the
was smooth
usability of this?
because the same test script can handle multiple, because that's one API call we have done in this example, right?
Yeah,
So you can have multiple, let's just for example, right? On internet banking, there is a login page, then there
yeah,
is a landing page,
yes,
then there are services page, then there is from services, if you want to go to a ATM card, then it's linked, it's a breadcrumb, right?
correct.
So it's all linked. The entire scenario can be simulated here in the
Okay,
same one test case.
right.
And that's that's how, and believe me, if you want to do browser testing, that's also possible here. You can just have the Chromium
Yeah,
executable file. K6 supports that as well,
okay.
and there's already a documentation, clear documentation, given how you can do a browser testing. It's just you need to have, if your application is a web SSO based application, then you need to be very much careful that that's a technical account, because use human account might not be feasible, because it requires two-factor authentication for
Yes.
most of the application for security. But if you have username password, then it's straightforward. Again, yeah, if it is username password, right? That you would, I mean, many of the enterprise companies, or in fact all of them, due to security reasons, might not allow the password to push into our pipelines, correct? Raw password, right?
Correct, correct.
Here, K6, let me just jump to the test run. Right. Here you can define an environment variable which actually access the Kubernetes secrets. Okay.
Okay,
Which
yeah.
means you're just abstracting that password layer,
Okay, yeah. All right, understood. Yeah.
right?
Yeah.
Because it's cloud native tool, it can leverage all the Kubernetes offerings. Okay, so that's again, it's limitless. That's a very good question. And I was able to explain, how secret management also can be done with this tool, right? And if there is a load runner, or other Gatling or others, right? The password needs to be stored as a pipeline variable, again, which can
Correct.
be
That's right. Yeah.
exposed, right? Which can be easily exposed, right? But if you use Kubernetes secret, that layer itself is abstracted, and if let's say testers might not have the testers, or many other teams might not have the access level of viewing that secret, right? But once the DevOps team or any other team who has admin access has set up that secret, that's it. You can start using I mean, you need to use the name of the secret and the variable of the secret,
Yeah. Yeah.
right? And then that's it. You can just ha- use it for API calls as well, because not all API calls are open. Yeah, this was just an example, but
Understood.
you
Understood.
need API key, you need client certificates, right? Even the certificates can be stored as a secret dynamically. K6 can actually access those certificates, the API
Okay.
keys, right? And again, it's limitless. Whatever you
Sorry,
say,
sorry, Satpal. I'm just monitoring time a little bit. Yeah, what was the?
all right.
Did you find the thing you wanted?
Yeah, I'm just looking for it. Just give me 1 minute. Hopefully. Problem is, if I redeploy Grafana, right, I will lose all the data source, and configuration. It might take a lot of time. Just give me 1 minute, okay? I'm on it. It's
Please bear with us for a minute while Satpal finds the password he needs. Oh, was it a password? I can't remember.
no, it was a strange password,
Yeah.
which I deployed through Helm chart, Grafana Helm chart itself. Uh, Yeah. All right, I got it. So admin is the user. Cool. All right. Yeah. Now coming back to the reporting, right? Now you've seen the implementation, you have seen here how the test cases are deployed and how it happens, right? So Alloy is it's for scraping the metrics, throughout this namespace. Ideally, the container metrics and the kubelet metrics and all other metrics provided by the cluster or on the pod level. K6 here, it once the test is done, it will write it to Mimir as I've shown here, right? Uh, where is that? Yeah, as shown here, right? So this is the sorry, Mimir gateway where we push the metrics. Now, the the most important question and valuable question which everyone asks and looks for is, okay, we have got the setup, we have got things, but how do we actually capture it as a report? Right? And what are the parameters we look for? How this report not only the current or the live dashboard, but also shows the historical data to compare the patterns of yesterday's test run with the today's test run, right? So these all questions come up, but there's I've seen that those kinds of reports are not available really, because they need to be persist somewhere, and this K6 setup and all is a way, where we persist the metrics into our Mimir component, and from Mimir, as I said, right, Mimir stores the data 3 months, and we can also increase the retention period to 1 year as well, right? Depends on your use cases, but once you have that in Mimir, which means you have the historical data as well with you, right? So if I go to dashboard, I've set up a dashboard for K6 here. Okay, not the ideal one. So here you see the test run ID, which I have here, right? Okay. So yeah, this can be mentioned to ideally uh, categorize your tests, right? Have the naming convention of your test and easily can be identified here. So I'll select my test case here. Boom, right. So here you see I've just taken past 6 hours. I'll executed multiple times maybe. If I take 3 hours, it's like, yeah, 4 8. Now you see the network here, right? Total data received, sent, right? And data per second. These are quite critical metrics in terms of assessing the performance of your platform or the application, right? Here you see HTTP, the number of HTTP requests uh, versus the request which were success and failure, right? So all were there were success, and some of the critical metrics here is how the highest HTTP request per second. This is again critical metrics for us to understand the service mesh, right? How much threshold here it's only 38 requests per second, but I have reached 15,000 beyond that as well, where the systems couldn't handle the request, right? So that's where you know that, okay, if the request goes beyond this number, my system will fail. Ideally, the entire applications on that cluster, because service mesh is the gateway of your request responses, right, would fail. And again, no, this is from like testing the feature and testing the infrastructure as well. So ideally, if Istio is not, I mean, your service mesh is not working, then your application is also not working, right? So you're testing the platform component as well, and again your application, because applications resources might be less because microservices uses less CPU, less memory, and because there are multiple microservices, and each of the microservices you can actually have a single hit. I mean, like single test case, or as we were discussing about the question that Venkateshwar has raised, that if you have multiple APIs, right? So all that data also will be captured here for multiple APIs. Here you see, yes. So success request rate for here, it will show multiple APIs. If there are errors, it will show the errors. And beyond this dashboard, you yourself can actually put a query. I'll show you under explore, right? So
Just
in
while
the
you're
mirror,
doing that, Satpal, didn't the test also try to push up to 50 uh, virtual users
yeah, it did. So 50 is a target, which
or
means
target?
it
Okay.
has, yeah, it's a target. So there is a good documentation. You can understand about what is a target and what is an iteration. Okay, so iteration is something, if it has time, if it has already reached 50 target, it keeps on iterating the number till it reaches the time. That's 10 minutes maybe, or 2 minutes in our case, right? So we have given 2 minutes, 50 as a target.
Oh,
So
okay.
within two,
Sorry. Okay.
yeah, so within two
Understood.
minutes,
Yeah.
yeah, the target might be reached within 1 minute because it happens so fast, right? I mean,
Yeah.
over the
Understood.
network, it's too fast, right?
Yeah.
But it keeps on iterating that number till the time is up, right? So that's how you stage it. Okay. So, I mean, I would say try it out. You'll understand, okay, this is how it's happening. And you can come to a point where you can definitely understand how these targets are set, what is the outcome of it, right? But ideally, the what you're testing is your underlying use cases or maybe features, or maybe for example, document upload or download, how much network it's taking, how much where it's breaking, right? So all those what I'm showing is in a dashboard can be captured, right? So here you see all the K6 metrics, which I already was explaining you on the console, right? So here you see the fail rate, receive seconds. So it's all being done out of box, and this is historical data as well, right? If I go for last 6 hours, it will show the for just for example, check rate. So you have uh, the test IDs. If you have multiple test IDs, it will show up here, right? You can compare yesterday's with today's test IDs, having maybe timestamp generated dynamically through JavaScript itself. So you have other labels. So this is like uh, we have the current data, we have the historical data. You can pull reports, generate the graphs here on the dashboard to show up the spikes, right? So if I go to here, right? So here you see uh, and yeah, this is beautiful. Again, if you select this area, it will zoom in. Yeah, and here you see the virtual users count here and the all HTTP requests. So two jobs we are defined. So we are seeing two entries here. So if you define 10 jobs, you will see 10 jobs here, right? So you can go to explore, understand the metrics coming in, and then you can define your own dashboards here if you require more parameters, right? As I said, there's also I'll share the documentation. There's also provision to define your own metrics here of your name. Okay, so there is a function which allows you to do that, and whatever comes in the response, right? Based on that, you can fetch certain information because it's not that all the APIs will give the same response, right? There are certain headers from the APIs which are customized, right? And then if you want that headers to be printed, you can define your custom metrics here, and the same setup will work, and it will push the metrics to Mimir, and from Grafana you can ideally see all the data here, right? So what the setup, right? The observability setup should already there with many of your firms, companies, right? So there's the basic setup which it's already there. Your metrics collection, pushing the metrics to a observability tool, viewing that on Grafana. It's not only Grafana, it can be any other, visualization tool. Jaeger is for traces, or, you have got other, Cortex is one of the component like Mimir, which captures the metrics. Prometheus itself has that capability, right? So whichever tool you use, right? So K6 is just compatible with all the observability tools. So ideally, everyone would have the observability setup. It's just, you use the K6 setup and push your metrics to whichever tool you use and can be visualized on whichever tool you are using, right? Now, similarly, there is a component called XK6 Disruptor, which is used for chaos. Sorry, I couldn't show that today. But what happens is it disrupts the pods of my sample app. Okay, so it's also kind of image, and it can be run exactly how this setup is done. Okay, instead of the this runner image, we just need to use the XK6 disruptor, where XK6 disruptor, right? So we have this extension injecting the faults like pod disruption, service disruption, network delays. Everything is possible with this XK6 disruptor. So we do have this XK6 disruptor image. You see this, right? So instead of using the runner there, you can use this XK6 disruptor and then define your own test cases, right? So if you use, instead of this runner, if you use the XK6 disruptor, then your test script, right, has pod fault injections. You would see, or you'd also see, just for example, right, here you'd also see some, examples. So dynamically, when this load is applied, right? Let's say load is running, you can in between do some faults and check what's happening with your application, right? So in in any of our scenarios, wherever you're applicable, like if you want to disrupt the pod, to check whether the pod is coming up immediately in Kubernetes. If it's a plain vanilla VM Linux machines, right? You can apply certain thresholds, or maybe you can actually disrupt the service, which maybe a delay. What happens with service disruptor is, if you delay a service, how your underlying infrastructure is behaving, you would know whether it says 404, whether it says 503 service unavailable, or whether it says 500, the server itself is not available, right? All these kind of assessments can be done through the disruptor. But in an application use case, you can see the service disruptor is quite effective. The network latency you would also apply. In that case, you delay the network. K6 can in fact tweak certain parameters on the network which delays the service calls, and you can see the latency is also captured as shown, right, in the output. The network here, right? So here we have only data received sent, but under network you would have more.
Sorry,
um,
Satpal, just to say we need to wrap up
yeah.
the talk in the next
Right, right.
5
Sorry.
minutes or so.
So yeah. So this is about, the I'll just with two sentences I'll wrap this up, right? So ideally you have seen that observability into your system, the performance of your system is key here, whether it may be because infrastructure and application both go hands in hand. In infrastructure is the one is hosting your application, right? So you get insights of your complete environment here. and the possibility is not only limited with your API calls or only API testing, but it can go beyond with all the technical tools or the distributed systems along with your database, Kafka, Redis, or any other technology tools which is hosted on Kubernetes or your virtual machines. So the recommendation is, go with these tools. You will slowly understand about how powerful this tool is. There is K6 Studio available. There is a standalone K6 application available, which can be used for all-purpose testing. Yeah, that's it.
Thank you very much. Thanks, Satpal. Great round of applause there for you. Really appreciate the talk and the knowledge sharing. Thank you.
Thank you. Thank you so much.
Are there just any questions? A very short Q&A. Are there any questions